To analyze the current and voltage in a capacitor, we introduce a quantity known as the capacitive reactance. And this quantity is symbolized by X sub C. If it's clear that we're talking about a capacitor, then sometimes the C is dropped and we just write reactance X. Now, reactance is measured in ohms, and it works just like resistance, except that it is out of phase with ordinary resistance. You remember that the voltage across a capacitor is out of phase by 90 degrees from the current. In fact, it lags by 90 degrees. And therefore, to have the voltage work out right, we must have the capacitive reactance lag the resistance also by 90 degrees. Now, to calculate the reactance, we need not only the component value, which is the capacitance, we also need the frequency of the source voltage. And once we have these, then we can use this formula to calculate the capacitive reactance, 1 over 2 pi Fc. Okay, so for example, we're given a value for the capacitor, 0.1 microfarad, and for the frequency 8 kilohertz, we need to find Xc. Okay, so plugging into the formula and remembering that K represents 10 to the third and the micro represents 10 to the negative 6, then we can plug this into our calculator and get the answer. And I'm going to calculate that denominator first and then take the reciprocal. That's easier and less prone to error. So here we go, 2 times pi. Your calculator should have a pi key, so you don't need to enter 3.14. And then times 8 times 10 to the third. That E3 means times 10 to the third, as you know. And then 0.1, negative 6. Okay, so there's the answer. And remember, we need to take 1 over that, so that button there will do it. And we get our answer, which is about 199 ohms. Okay, so although it should be obvious, I'll repeat for emphasis that the value of the reactance will depend not just on the component value, the capacitor, but also on the frequency of excitation. And the higher the frequency, the lower the capacitive reactance. Also, the higher the capacitance, the lower the reactance. Do one more calculation on reactance. All right. We have 30 picofarads and 580 kilohertz. Okay, so there's my previous example. Now for this one, we have 2 pi times 580. Okay, and then times 30, and you remember the P means 10 to the negative 12. Pico. Okay, so here we go. 2 times pi times 580 times 10 to the third times 30 negative 12. Okay, and then finally we take the reciprocal of that to get our answer, which turns out to be about 9.15 kiloohms. And I've rounded it off here in the notes. Next concept, the impedance, which we've run into before, is the phasor sum of resistance and reactance. Okay, so for example, we're given value for a resistor 300 ohms and the value for capacitive reactance 200 ohms. We need to find the impedance and the phase angle. Okay, so let me first draw the phasor diagram so we know what we're doing. In an RC circuit, we have the resistance on the reference x-axis there, so that's 300, and then XC here is 200, negative 200 actually, but we're not going to worry about that. And then Z is the diagonal there. Okay, the phase angle is always measured from the x-axis. So there's theta. Okay, so here's the diagram. To calculate the magnitude of the impedance, square root sum of the squares, we get 361 ohms. And for the phase angle, we do the inverse tangent, and we get 33.7 degrees.